Okay, in this video we're going to look at the potassium permanganate, iodine and sodium thiosulfate titration. We'll be doing one question from the book and also a whole exam question from 2015, which was question 1. So if you want to pause for yourself and read through this question first of all, and then I'm going to do the maths part of it, which is part 5. Okay, so what we're going to do is we're just going to underline the important sections. Potassium permanganate is our oxidizing agent here. And the sodium thiosulfate is average titer is here, which is our reducing agent. We have these two equations to look at. So we have two equations because the first equation happens in the conical flask when we mix our potassium permanganate, our potassium iodide, and our sulfuric acid together to liberate this iodine here. That iodine then is titrated against the sodium thiosulfate. So we have to use both of these equations simultaneously to answer this question. So the question is, calculate the concentration of the sodium thiosulfate solution in moles per litre and then in grams per litre. So what I'm going to do is I'm going to look at all of the information I have under the two headings of the oxidizing agent and of the sodium thiosulfate. Okay, so I have 25 centimeters cubed of the potassium permanganate section. The molarity was 0.018 molar. And I have no other information. Well, I have the information in regards to the chemical equation here. We can see we have a 2 in front of the potassium permanganate. So I have that information as well. So I'm just going to write N equals 2 here. This is the volume. And then this is the molarity. Okay, so we need volume, molarity, and the number for the reducing agent as well. And we can see that the average titer for the reducing agent was 15.6. The molarity we don't know. That's what we're trying to figure out. Moles per litre of sodium thiosulfate. And then I need to figure out what number to put for the sodium thiosulfate. Now you may be tempted to just look at this and say, okay, well here I got the number for the potassium permanganate. There's no sodium thiosulfate in this reaction because that is in the conical flask. But there's a 2 here in front of the sodium thiosulfate. So I'm just going to put in 2. But that would be incorrect because we need to work with these simultaneously. So the 2 moles of sodium or potassium permanganate produced 5 moles of iodine. So what I need to do is I have only got 1 mole of iodine here. So there's an imbalance between the two equations. So I need to multiply this whole line by 5 so that equation 1 and equation 2 actually relate to each other. So this new equation is going to be 5 iodine plus 10 sodium thiosulfate goes to 5 of this compound and 10 of the iodine ions. Okay, so now you can see that the number in front of the sodium thiosulfate is actually 10. Okay, so that was relating the first equation and the second equation together. Okay, because I have 5 iodine here, I need to have 5 iodine here as well, so that they link. Okay, so now I have that. I can use this equation, molarity of the oxidizing agent times the volume of the oxidizing agent under the number of moles of the oxidizing agent, molarity of the reducing agent, volume of the reducing agent over the number of the reducing agent. Fill all of those in. We're going to get 25 for the volume, molarity 0.018 over 2. We don't know the molarity of the sodium thiosulfate. The volume is the average titer, and the number is 10. So when we work this side out here, we're going to get 0.225 equals the molarity of the reducing agent times 15.6 over 10. I'm going to bring that 10 across and multiply it into the 0.225, which is going to get us 2.25 equals MR times the 15.6. So then MR equals 2.25 divided by 15.6. So the molarity of the reducing agent is 0.144 moles per litre. And that is for the sodium thiosulfate. Okay, so that's that A question completed. We need to get the grams per litre of this crystalline solid, which is the sodium thiosulfate. And this is part B of the question. For that, we're going to use this formula. Number of moles equals mass over relative molecular mass. So we have the number of moles, 0.144. We're trying to find out what the mass is. We need to get the relative molecular mass. And we can do that by looking at this here, Na2S2O3 times 5,2H2O. And looking at our periodic table to work out what the relative molecular mass of this compound would be. So what I've done is I've looked up all of the relative molecular masses of the single elements. 2 times sodium, we have 2 sulfurs, 3 oxygens. We have 10 hydrogens because the 5 and the 2 multiply together to get 10. And we have 5 oxygens, 5 times the single oxygen. Multiply all that together and we're going to end up with 248 for the relative molecular mass of the substance. So we're going to put 248 in here in the equation. Multiply 248 by our concentration and we'll work out the mass to be 35.712 grams of sodium thiosulfate in a litre of solution. So that's the mathematics part of that question done. Now we're going to take a look at this exam question. So this is from 2015, question 1. We have a few procedural questions on the side here, A, B, C, and then also E is procedural. So I'm going to be going through all of them and we can work through it. So if you want to read through it first of all, maybe give it a go, pause the video, and then I can give you a solution. Okay, so here's my answer for question A. Explain how iodine, a non-polar substance of very low water solubility, is brought into aqueous solution. So basically, iodine will not mix with water because there are different polarities. So iodine is a non-polar substance, i.e. no overall charge or dipole on the molecule. Okay, so water is charged and there is a dipole on the molecule. So there are different polarities. So when iodine actually reacts with the excess potassium iodide in the conical flask, this following reaction occurs. we have the iodine that's produced from the reaction. We can scroll up for a second. This reaction here, see this iodine? That iodine is reacting still with the excess potassium iodide that's in the conical flask, producing this charged ion here. Now this charged ion behaves exactly like iodine and is produced in the conical flask. The ion is charged, so it's readily soluble in the water as it's polar. Okay, so it has an overall dipole on the molecule. And because like dissolves like, this allows the iodine to be soluble within the water. And that's your answer. So now we're going to try and answer B. Okay, so the starting points for B, we can see there's 12 marks going for it. But you should write as much as possible for this question. And make sure that all of your sentences are clear and they follow in a specific order. So the first one is pour the iodine solution into a clean, dry beaker. Then you want to start cleaning out your pipette. So clean the pipette or rinse the pipette with deionized water.